Welcome to Chapter 2, Section 3, Adding and Subtracting Rational Numbers. Our goal in this unit is to add and subtract decimals and rational numbers, fractions, with like denominators. Example 1. In August, at the World University Games in Beijing, China, Jimrick Hicks ran the 200-meter dash in 24 and 8/10 seconds. Her best time at the U.S. Senior National Meet in June of the same year was 23 and 3500 seconds. How much faster did she run in June? Well, as a reminder, whenever you're adding or subtracting decimals, you need to line up the decimal places. Put your decimal down here. So we're going to line the decimals, and then we're going to subtract. 8 minus 5 is 3. We're going to borrow. 10 minus 3 is 7. This becomes a 3. So it's 73 hundredths, or 73 hundredths seconds faster. Now, how did I know to subtract? Well, it was how much faster did she run. So we're looking for the difference between the two. And that's how I knew to subtract. Now, you can also use a number line to add and subtract rational decimals. In this case, we have a number line, and we're going to find the sum of 3/10 and 1 and 2/10. So that's a negative 1 and 2/10. So we're going to first move right the 3/10. And from the 3/10, here's 0, here's 2/10, here's 3/10. So we move from 0 to 1, 2, 3/10. And from the 3/10, we're going to move left. This means left, 1 and 2/10. So we're going to move left 1 and 2/10. Well, here's 1/10, 2/10, 3/10, 4/10, 5/10, 6, 7, 8, 9, 10, 11, 12. So here's 12/10, which is what this is. And this would be a negative. That's 1/10. It's not quite 1/10. 2, 4, 6, 8, and one more. That's 9/10. So we finished at negative 9/10. So 3/10 plus a negative 1 and 2/10, which, like you saw, became a negative. We move in the negative direction, is equal to negative 9/10. Let's look at example 2b. In this case, we're looking at fractions, and we're going to use the number line. And we're going to move right 1/5 of a unit. And from the 1/5 of the unit, we're going to move and right again another 2/5. 1/5 plus positive direction, move right again 2/5. So we start at 0 and we go to 1/5. This is our starting point. From 1/5, we're going to go 1 2/5. So this is our ending point. So we finished at 3/5. So 1/5 plus 2/5 is equal to 3/5. Adding and subtracting rational numbers with the same denominator. So rational numbers with the same denominator are fractions. We add or subtract the numerators and keep the denominator. Very, very similar to what you have done all along. And even if we don't have the same denominators, usually start by getting the denominators the same. And then we're going to add or subtract the numerators. In this case, this would become subtraction. So you have 1, you owe 4. Have 1, owe 4. Positive 1, negative 4, which means you owe 3. Or positive 1, negative 4. Signs are different, so you subtract. 4 minus 1 is 3, and you take the sign of the larger. Now notice negative 3 over 5 is the same as saying negative 3 over 5. And so you'll see that written both ways and be able to change it around in your mind. Algebraically, because that's where you're going with this, we're going to do the same thing. If we add or subtract any rational numbers, we're going to add and subtract the numerators, as long as the denominators are the same. If the denominators are not the same, we're going to first make them the same, and then go ahead and add and subtract. Let's look at a couple problems. This is example 3a in your notebook. So for this unit, we're going to keep the numerators, or subtract the numerators and keep the denominator. So we have negative 2 ninths minus 5 ninths. So we're going to have negative 2 minus 5 over 9. You need to write that in your notebook. If you owe 2 and you owe 5, you're going to owe money. And you're going to owe $2 plus $5, so you're going to owe $7 over 9. Owe 2, owe 5, signs are the same, so we add them, and we keep the denominator. Let's try the next one. I wrote this hint down because I really want you to be aware of it. This negative 3/7 can also be written as negative 3/7, and you're going to see that both ways, so keep that in mind. But when working this problem, we're going to realize that 6/7 plus a negative 3/7 signs, no numbers in the middle, so we can combine them and make a minus. So this is going to be 6 minus 3 over our common denominator that we keep, 7. So our answer is 3/7. It's a positive 3/7. This is example 4. Now, when we evaluate an expression for a given value, we do it just like we did in Chapter 1, Section 1. You're going to take the negative 1/10 and you're going to put it in for the x. And when you put it in, you're still going to put the parentheses around it. So we're going to substitute negative 1/10 for x. So putting a parenthesis around it, we're going to put in negative 1/10. Now think about this. Negative minus negative means we're going to think add. So this is 12 and 1/10. Two negatives make a positive. That's made that. 1/10. 2 and 1/10 plus 1/10. Okay, line up your decimal points. Bring it straight down. 1 plus 1 is 2. So that's 12 and 2/10. One more example for you. This is also in your notebook. In this case, we're going to substitute 3 and 1/10 for m. So we're going to put in parentheses 3 and 1/10 here. Now, to do this, we need to make this into an improper fraction. Now, yeah, I know. Some of you are a little more on the ball with fractions, and you can do that without doing this. But we're going to make this into an improper fraction. Now, to remind you how to do that, it's 10 times 3 plus 1. 10 times 3 plus 1. This is 30 plus 1 is 31. So 3 and 1/10 is 31/10. So this becomes 7 plus 31. Again, we're adding the numerators and keeping the denominators. So this is 38/10. And then we do have to simplify. 10 goes into 38. You can do it over here. It goes in there 3 times with the remainder of 8. That's 8/10. This equals 3 and 8/10, which also, if you divide the top by 2 and the bottom by 2, they're both divisible by 2 because they're even, you get 4/5. Well, at this point, that's it. You have one. Try this. Do your best on it. Remember to line up your decimal places and fill in the zeros. And I'll see you in class tomorrow.